Hi again, everyone. This will be the last video in 8.1. Hopefully you tried this one out. The tangent of theta equals 4. We need to find the value of theta in degrees and in radians. So the first step, just like any trig ratio, trig function, they have inverses. So the first step here would be to take the inverse of both sides. So here it's the inverse tangent being applied to both sides. Why do we do that? Well, because the inverse tangent and the tangent cancel out. We need to isolate theta. Theta equals the inverse tangent of 4. Then grab your calculator, maybe have it in degree mode at first. Find the inverse tangent of 4. However your calculator does that, I just did it myself, and this is the answer that I got. I rounded to 3 places. The question didn't say how to round. I just went with this. In degrees, it's 75.964 degrees. So if there was a right triangle, to get a ratio of 4, we can even just draw like kind of a quick sketch of what's happening. If this is our angle theta and tangent is opposite over hypotenuse, hey, if it's 4, you could think of it as 4 over 1. If that was what angle would create such a ratio that this is 4 times bigger than this? And it appears my drawing is not to scale, but imagine that's 4 times as big as this. What angle would it be? 75.964 degrees. It'd actually be, probably a better drawing would be something, something like that, right? There's 4, there's 1. 75, almost 76 degrees. I also revealed my answer in radians here. Okay, if I convert to radians in my calculator and do the inverse tangent of 4, I get this 1.326 radians when I round it. So there you go. To make more sense of a number like this, if you remember that pi is going around 100, if I went around 180 degrees, that would be 3.14 pi. So it takes 3.14 radians to go this far. It makes sense that it would take 1.326, just to get to there. That's what's happening with the radians. A lot of times we think of it with pi, but if we remember that pi is a number, okay. I think you get it. So what other kind of problems are we going to see? Well, this is the majority. These are the mainstream problems. There's a couple of applications, of course. But really, we're going to think of those in the same way. They're just going to be described in words instead of giving us a drawing. So this is a good one. A boat captain sees the light from a lighthouse at an angle of elevation 12 degrees. So he's looking, out and up a little bit. 12 degrees up, he sees the light from the lighthouse. The light is on the shoreline, of course, 50 feet above the land. So that's how tall the lighthouse is, right? How far from land is the boat? So that'd be good for him to know. And he can calculate that. If you make a sketch, here's my sketch of, here's the boat out at sea, and there's the sea, here's the land, and the light is up there. So he's looking up at that light. That angle here is 12 degrees. And sorry that's a little dim or maybe a little fuzzy. That's what's happening. Okay, so how far is he from land? That'd be good to know. Well, let's simplify this drawing a little bit. If I make a right triangle instead, I've got my angle. This is what I would like to know. And I know that that light is 50 feet above the land. Okay. So if I know this angle is 12 degrees, I know that's 50, and I would like to know this distance along the bottom. The question becomes, which of the 6, or maybe even if you just think of the first 3, which of those first 3 trig ratios is going to come in handy here? Is it sine, cosine, or tangent? And after thinking about that for a moment, you think, well, sine is opposite over hypotenuse, but I don't care. I don't know anything about the hypotenuse. Cosine is adjacent over hypotenuse. Well, that's what's in question, but again, the hypotenuse I don't know. Tangent is 50 over this. That's the one I want, tangent. I know by looking at this drawing, the tangent of my angle, 12 degrees, is 50 over whatever that is. Maybe I call that x, right? Tangent 12 degrees equals 50 over x. Once I have this equation, I'm pretty fast to the answer. I can multiply the x over. I can divide this entire thing underneath and say x equals 50 divided by the tangent of 12 degrees. And putting that into a calculator, 50 divided by the tangent of 12, make sure you're in degree mode. Going to be jumping back and forth between them. Hopefully, if you try that out on your own, you get this answer right here. The boat is 235.23 feet from the shore. Again, I rounded to 2 places. It didn't say. And that's a reasonable answer. 235 feet, 235.23 feet from the shore. He's pretty safe. For now, he knows that he's getting kind of close, but he's probably doing okay. All right. That is it for 8.1.